Hello, everyone. Good afternoon. Welcome to today's data cleaning in R workshop. My name is Chen Cho, and I'll be the person presenting today. And Marty and Bonnie here, they are our TA. And if you have any question or need any help, you're welcome to send a private chat to them, or you can post on the public chat here. And one of them will be able to assist you. We are from Data Services. We based in Sheldon Library, but we help people both in Homewood campus and in medical campus. This is our email. This workshop, the meeting will be logged at about 30 minutes into this workshop. So in case you get left the meeting, you log out Zoom and you need to come in, the meeting will be logged. So this is the email that you can send to, and then you can ask to be rejoin the meeting. So dataservice@jhu.edu. And of course, after this workshop, if you need to have any data related question, you can send to this email too. This is our website. It has a lot of information about our services and then also our workshop information and some resource about data management and sharing. This is our data archive. I'm going to cover it a bit later. Okay. Okay, so before we start, a little bit about Zoom. I'm sure everybody is familiar with this interface, but just want to mention a few things. So first, mute your audio and video unless you want to ask a question or want me to repeat something. And if you need to ask a question, there is a raise your hand thing. I don't have it as a host, but I think it's somewhere here. So you can raise your hand and one of the TA will come to you and try to answer your question. Or if just I go over something too fast and you want me to repeat, you can unmute your microphone and then say, could you please say that again? And I will do that. And then you can also use private chat or public chat to ask your question. We will give the priority to people who do the raise your hand thing. And then also when you go to your participant list, you will see this yes and no here. So you can use that to say, so we have some hands-on activity and there'll be like, I will ask, have you done this? Are you done? And then you could say yes or no. And then, or you could ask question. Okay. And if you see this in one slide, that means a checkpoint. We will have a few checkpoints along this workshop to make sure that everybody is following along. So about this webinar, the webinar will not be recorded, so you won't get a recorded copy after the workshop. TA will send out a link to a folder. I think they are going to post it in the chat right now. And that link, if you register in Zoom early, then you probably get an email from me this morning about access to this folder. So basically this folder has the stuff that we are going to use today. You will see a zip file with R project and data, and there's a PDF file with today's slide, and then also cheat sheet for your reference. And you will get the following material. You will get an R script for the hands-on activity today. So here is a checkpoint. So can you access the folder with class material? If you cannot, please just do no. Just give me this no. If you can, just do yes. Okay, so some people get it, some people don't get it. Okay. Okay. So I post a link there so that the TA know if you still cannot access those material, So I will be talking about some general concept about data cleaning for the first few slides. So here is your chance to download the material in that folder and then put somewhere in your computer, wherever you like. Okay, so if you still have trouble, ask the TA. So TA at the same time is the co-host. So if you don't remember their name, you can just scroll up and then they are the co-hosts for this webinar. Okay, just a bit about data services before we go into the data cleaning. So we have 3 areas of services: consulting, training, and archiving. So consulting, we start by helping people with their data management plan. So that's the we used to be called data management services. And then later we expand our services to help people access data and discover data. And then also we merge with GIS department, and we also help people with geospatial data, set up ArcGIS, and visualize your geospatial data. Training like this one, we have a series of R workshop. We also have an introduction to Python workshop for absolute beginner. We have best practice for data management and sharing. If you are working with PHI data, you need to share your data with other people. You need to de-identify your data. Then we have a workshop about de-identification. And also some workshop about open science and tool and ArcGIS and web mapping. If you heard of story maps, we also have a training about story maps. Archiving, it's this JHU data archive. You can visit there, and it's basically for JHU researcher. If you submit a manuscript and the editor say, hey, you need to share your data, but you don't know where to share your data, you cannot find a good data repository, then you are welcome to contact us and we will help you share your data on JHU Data Archive. Just a note here that it's open to anybody. So if you have PHI or PII data, you need to properly de-identify them before you upload to our data archive. So any question about our services, you can send an email to us. Okay, so we hope that when you attend this workshop, you have some basic knowledge about R. So before the workshop, I sent an email asking people to install your R package. So I hope you got to do that. If you haven't and have trouble, you can contact the TA. And then you know some basic terminology in R. So when I mention it, you will understand what's that mean. It would be nice if you have some messy data already and then you need to clean that. Or you have previous experience on dealing with messy data and you know how hard it is. But you can still ask any question at any time. Don't feel it's a dumb question or will waste other people's time. We want you to be able to follow along. So anytime you have a question, put it in the chat or ask TAs. Okay. This is a link for our class pool. So I want to use this pool everywhere link to gather some information from people. So it's poolev.com/dataservices051. I'll also put this in the chat so you can link to it. Okay, so the first question is, which school are you from? Okay, School of Public Health. We usually get a lot from public health. Okay, good. Looks a lot for medical area. Okay, so the next one, what is your position? Okay, got a lot of graduate students today. Good. Have you taken our intro to R workshop? for absolute beginner? Even if you didn't do it last week, you did it before, that's okay. Okay, good. A lot of you take that. Okay, what's the level of programming knowledge? Any language, doesn't have to be R. Okay, mostly beginner, great. Got some advanced and intermediate too. Okay. So when you're thinking about cleaning your data, what tool do you use? What software do you use? Okay, Stata. SPSS. A lot of Stata. Okay, some people use OpenRefine. Good. That's a good one. Okay. Some people use Excel. Good. Okay. So when we talk about messy data, usually if you heard it saying happy family are all alike, every unhappy family is unhappy in their own way. So it's the same with clean data and messy data. So tidy data set are all alike, but every messy data set is messy in its own way. So it's hard to say, oh, it will be messy in this way, so just clean it this way. It will be messy in different way. Okay, so this is just an example here. And I want you to use the public chat. And if someone can type in, what do you think is wrong with this data set? Why it is messy? Okay, people mention missing value. Yes, there's a blank here, so we don't know what's that mean. It's blank. You didn't take any data or what happened? Okay, anybody can tell me what's wrong this column? Mixed value, yes, yeah. So one cell should just have one number, and this person just makes an engine and engine size and type together. And even like this one, it has 3 set of information, 1.5, 4, and hybrid. Okay, inconsistent formatting. Can you explain more about inconsistent formatting? Okay, yeah, like this one has 3 pieces of information instead of 1. So the best way is just have 1 information in 1 cell. Okay, did you guys pretty much nail it? So like this one, 2 value in mostly 2 value in 1 cell, but this one have 3. This one, so it has male and female. So basically this number tells you one male has this model of car, one female has this model of car. And then this tells you one male has it, none of the female. Hopefully it's none of the female, because if it's none, it should say 0 instead of leave it blank. Missing value there. Okay, so this one have some, it's already marked red, so I'm going to just go over it. So this one seems like in the wrong cell because they say AKA name, and then it should be here, I think. And then Chicago, but this has a typo. And then this has zip code. It all has the same address, but the zip code are different. So which one is the correct zip code? You probably can find out the right answer in the Google map, but it just takes some extra time to find it. Okay, so why you need to clean data? So what is data cleaning? Sometimes it's about remove incorrect information. Sometimes it's about fix inconsistency. Sometimes it's about identify missing value. And of course, there are more here. And why you need to clean data? Because you may get data from different sources and you want to combine them together to do more analysis. So it's important that you have all the clean data sheet and then they are all in the same format, so you can lump them together and do further analysis. And it's also make it easy to visualize your data and make data more reliable and reusable. So we talk about cleaning data in R, but there are actually two parts. One is data cleaning, one is R. So which one of the following statement can best describe you? Okay, good. Looks like most people know data cleaning, but don't know how to do it in R. Then also I will show you like why data is not messy and how you clean it. But actually the important part is you look at a data set and you already in your mind decide how you want to clean it. What's the step you want to clean it? And then R is just a tool to help you accomplish your goal. So it's the first step, the most important step is go over the data. Okay. So what you will learn today, you will learn how to import CSV file into R, and you will explore data set and know what is a tidy data set and how to make your data tidy. And then how to select and filter your data. And sometimes you want to recode your data. So the code, other people's data set, they code it in a way that's not consistent with your own. So you want to make them the same. So you want to recode them. And then in the end, you will get some resources and to learn more about data cleaning. Okay, I asked people to install the Tidyverse package. And it's actually a collection of R packages designed for data science. And you can install the whole Tidyverse package, or you can choose to install individual package. And if you want to learn more, here are the website you can learn more. Okay, I hope everyone already installed a package, because before you load a package, you need to install a package. So you may be thinking, okay, should I load Tidyverse package or should I load individual package? The individual package we will cover today in this workshop is one is TidyR, one is dplyr. So do you want to load the whole thing, or do you just want to load TidyR or dplyr? So I will load individual package for this workshop. And this is just show you which function belong to which package. And then we use this command to load a package library, and then you put package name in the parentheses to load a package. So some of you, when you try to load a Tidyverse package, you may find that, oh, actually it has a warning, say, some function in another package is being masked. So this is the problem when you load a whole package. When you load a whole package, sometimes people are not very creative about function name. So it's very possible that one function name could be the same in one package, in two different packages, but they may define differently. So in order to distinguish them, every time you load a package, it override the function in previous package. So you will use the definition of the latest package. So sometimes people choose not to load the whole package. If you don't want to load the whole package, you just want to load one function in one package, you can use package name, colon, and then function name. So you just use this way, you just load one function in one package. You won't load a whole package and then cause some masking happening. I'm going to demo that one a bit later, so you will see what I mean. But if you can open the cheat sheet I sent you, no, you download from that folder, you will notice that they have a package name in the front, like dplyr ::, or tidyr ::. So that's how you load one specific function in one package. Okay, so this is something I hasn't covered in the introduction to R workshop. So this is one thing called project. So R project is if you download the data cleaning R folder, it's a zip folder, and then you unzip it in your computer. And then you will see that there are a folder called data, and there is also another file called R project. .r project. So I think it's data cleaning R.r project. So if you double click that one, it will open RStudio for you. And then wherever you put that folder, that will be your working directory. So if you need to save your work today, R project and R history, it's auto save. But the script you write today, the data you work on today, and if in the future you do data visualization, the plot you plot, you need to save it yourself. And then if you need to write comment, use the hashtag. Okay, so I want to check with everyone. Can you open the file data cleaning R.r project? Just do double click. So I'm going to demo this too. Okay, here is my folder. It's a bit different than yours, but you should get this zip file and you should unzip it. And then you should get something like this. You get R project and data. You don't have script because I didn't send you that. So just double click this one. And if you want to start a new script, just do new file and R script. And it will show up here. Okay, give me a thumbs up or yes, the green yes button to let me know if you got it. Good. See a lot of. Good. Glad you are able to get this. Okay, so if you still couldn't find a file or couldn't download it, let the TA know. So if you, wherever you put it, if you need to know your working directory, just go to your console and do get WD without any argument. And this is your working directory. So the good thing about R project is that if you ever work with other programming language, you will know that sometimes it's just good to find a good, it's just good, need to know where is your working directory. So the computer know where to get the data and you know where you save your data. So an R project is a collection of file and possibly data, result, and graph, depends on what you save in there. So the purpose of R project is to keep your analysis organized. So, and you can simply share your project like I did. I just shared with you a whole file, a zip file, and then you double click the R project, and wherever you put it, that is your working directory. You don't need to go into the code. You don't need to go into the script and then change it to your own working directory. It just do it for you. So that's make your code more portable. So an example like an R project folder can look like this. So it's your folder and this is R project. And of course, you should include a README file. And then you may put your data there. You write some paper related to this data set. Your R code is there. And then maybe this is your manuscript writing file. So something like that. If you want this R project, I sent to you. But if you want to create your own, you can do File, New Project. But I'm not going to demo that right now because I don't want to create another new project. But just do a new project and then follow along, like new directory and new project. And then just give it a name and put in wherever you want. And later, when you come back, you want to look at this project, just double click this file, this R project file, and you will have RStudio open for you. Okay. This is about our project. So let's review this a little bit before we go on. So data type in R. So you need to know your data type before you join two data set or before you clean your data set. So some basic data type in R is character, numeric, integer, logical, and complex. And then you can use class to find out your data type. And sometimes the data type in the file you import is not something you like. You want to change it. You can use this like as.numeric means change this column into numeric. As logical, change this column into logical. As integer, change this column into integer. So this is probably in a case that you got other people's data set and they didn't define the column, the variable to the right type, then you need to change it. So it's important to find out what's the data type they have and change to the appropriate one that you want. Okay. Sometimes when you like combine or row data set, there are some correlation rule. So for base R and dplyr R, they are different. So for base R, R will convert it automatically for you. So it will convert to a more general type. So the order is roughly like logical. If you combine these two, it will coerce it into O integer. And then just keep going on. The character is the most general one. And if you use dplyr R package to load the data, it won't automatically do that. It will return an error message. Sometimes an error message like this is a good thing because you realize, oh, there are different data types. So you know you need to go fix the problem. So the only exception is the factor. It will convert factor into string, but it will give you a warning. Okay, so I hope everybody still remember this data set. Actually, the first example in this workshop is to clean this data set. So I already saved the data here into a CSV file called car purchase. You should be able to see that in the data folder. So you don't need to type in anything. You just need to load this CSV file. So of course, the first step is let's load the file. We use this function called read.csv. And there are a few important arguments in this function. One is header. Header equal to true means it will see the first line as header. And this is the default. If you don't want it to happen, you need to set it as equal to false. NA.string equal to something. So this is used to define what counts as missing value, because different people may define this missing value differently. If I leave it blank, that means all the blank cell will be missing value. So R will assign NA to that cell. So maybe there are other things you want to assign as missing value, like some people use NaN, some people use like -9999, or maybe sometimes you want to exclude some value. So that's something to put in this argument. And then another argument is string as factor. That means if you import character data, like those text data, it will see it as character. So the default is true. But if you don't want that, then you need to set it as false. So this is not something that I magically just know. So if you want to know what argument you should put in, I hope you remember how to find help document from the intro to our workshop. If you don't remember, just do question mark in your console and say read.csv and say enter. And it will show up here. So you will find read CSV is here, and then it tells you the default value, and then what kind of argument you have here. And then if you scroll down, it will have detailed information about the argument. So that will help you decide what to put there. Like NA.string is defined here, and then this string as factor defined here. Okay, so that's a good resource for you to find out what each argument is and how you are going to use them. So now I want you to roll the car purchase data set. And then this is the command you need to enter. I assign the data I load into this car variable. So of course you can name it whatever you want, but car, it's just like, you know it's about car. And then read CSV, since our R project will only find things in that project folder. So I say, okay, go to that project folder, find this data folder, and then find the car purchase data set in there. And then I want all the blank cell to be assigned as NA. And I don't want you to read all the string as factor. I just want character data. I don't want factor data. So you can type in this in your script. And then once you did it, you can do run, or you can do Control Enter. And you will be able to run this command. And when you do view car, you should be able to see if you load it successfully. Okay, I'm going to switch to the, so you can write your code, you can write a comment. I'm trying to load car purchase CSV data set. Okay, so I call it car. And then read the CSV. So you can highlight this and then do run. So you will see if it show up in your console, that means it's run successfully. You shouldn't see any error. Or you can put your cursor here and then do Control Enter. It can run too. So if you want to know if you did it successfully, do view and car. So it should show up like this. Remember, the V is the uppercase, not lowercase. Okay, once you are done with entering this command, you notice here it say untitled because I haven't saved the file. So you can save it. So I'll just save it. I can call it car purchase analysis. No, this is cleaning. So you see it replaces the name and then the asterisk there is gone. That means you already saved this file, save the change. Okay, I'll leave this here a little bit so you can type it. So is everybody being able to see your car data set? Okay, good. See some people check yes. Okay, good. So that's the important first step because we need to be able to see the data set in order to clean it. Okay, I'll just give a couple more minutes because I saw two people raise hands, so want those to be able to resolve first because it's important.
Could you repeat how to save the file?
How to save the file?
Yes.
Or how? We haven't reached the save the file part. That will be the last part of this data set, but right now I'm just loading the data set.
Oh, wouldn't you explain that it said untitled?
Oh, that one. Okay.
Yeah.
Sorry. Let me see. Yeah, that's save your script. So you could click this. I cannot because I already saved something. Okay, so I'll just do this. So I make some change so I can save it. But if it's your first time saving it, just click this and you will go through the window saying ask you what name you want to give it. And then you can just give a name and then .r, that's the extension for R script. And then you can save it. So you should be able to see it here if you save it successfully.
Thank you.
Sure. Okay, looks like everybody's good. Let's move on. Okay, so maybe you have some other file you work before, like different. I saw some people use SPSS, some people use SAS before. So maybe you want to load those files and you want to do analysis in R. So there are some packages that you could use, like this readr. It's for loading CSV file or text file. Heaven is for loading SAS, SPSS, data file. Read Excel, so of course it's for loading Excel file. So there are some documentation here that you can take a further look if those are file type that you use very often. Okay, so once we got the data set, we want to explore it because we want to know what's in this data set. And first, I will use this str structure. It tells you the data structure. So as I go over it, you can try it your own. You can say structure and then put car here, or you could do head and tail. Head give you the first 6 rows of data. Tail give you the last 6 rows of data. DIM is the dimension of the data, so it give you some idea how big it is. If it's too big, you shouldn't just like ask R to print out the whole thing for you to the get. You should just try head or tail. View, V is uppercase. You can view data as looks like a spreadsheet. Any NA, you ask if there's any NA in this data set. Summary, you get some basic statistic from this data set, and column name show the name for all columns. Okay, let me demo a few of them. I already typed structure. Could do head, tail, any NA. And you could do, okay. So you can run this few thing. So I want you to take a look at like what each one gives you, but I want to focus on the last one because last one, there is something I'm not too happy about. So anybody can tell me what's wrong with the column names of this car data set? You can type in the chat. Yeah, usually like this, like, so what I'm not happy about is this column name. So if you go to your view window, it has this dot, dot, dot. It's not because it doesn't have enough space, because even you make it bigger, it still looks like this. So usually that's not a very good variable name because it just fill in a blank with this dot. If you go back to a CSV file, it's engine space size, emphasis, and then type. So R sometimes did this kind of thing that they R just get smart and just guess what you want and then but guess it wrong. So this is not a very ideal variable name. I don't want to keep it. So I want to change it. So let's change the column name first to something that I'm really happy about. So I want to rename my column or a variable name. Okay, so there are two ways to do that. I'm sure there are more ways, but yeah, I'm just demo two ways to do that. Okay, first is base R way. So sometimes the people think that base R syntax is a bit awkward. So things like this, I want to change the column name in base R. I want this part equal to engine. So I basically want to change the column name. It was this. I want to change it to this one. So if you feel this is too awkward to remember, you don't like it, you can do a dplyr option. So like I just showed you, we are going to use a function in dplyr. But okay, I don't want to load the whole dplyr package. I only want to load the this function called rename. So in order to load it, I will do dplyr column, and then I say this one I want it to be renamed to engine. So I'll let you try to do it. So either one is okay, but just pick one to do, because once you use this one, it's already renamed. So it's not possible for you to rename the other one. So just pick one to do it. Okay, I'm going to switch out to RStudio. So I will do first option. So I like the second one better, so I will just run the second one. So if you go to your view window, didn't change it. Okay. Let me try the first. Not sure why this is not working. Okay. Okay. I think maybe I typed something wrong. Oh. Okay. I see what's going on. Okay. So you can see here, I should put the parenthesis here instead of here. So that caused the problem. Of course, the error message will tell you very clear what's that mean. So sorry about that. So when you go here, you should see that your engine is already changed. Engine name, no, the variable name already changed. Okay. Oh, yeah. I think somebody put in the chat that if you choose to use deploy R, you need to do this. Okay. So both should be working. I hope you are successfully naming your variable. Okay. So what is tidy data? You may hear people mentioning this, or say tidy data, it means clean data, right? But what's that really mean? So that means each variable must has its own column. So you cannot like put multiple value in one column. Each observation must have its own row, and each value must have its own cell. There are more definition. There are more example in this website. You can take a look, but first let's try some real example. So I have 4 data set here, and I can tell you that only one is tidy. So, but I know it may be hard to decide. So I want the next question, I will do the pool question, and the question asks you which one is definitely not tidy. So you only need to pick one that's not tidy. So I'll give you a couple minutes to decide. And there are 3 data sets that's not tidy. So hope you won't find it too hard to give me an answer. I know the slide you got, you have the answer in the following slide, but try not to pick on the answer. Okay, some people type in A, B, D are not tidy. Okay, so hopefully it's active. Yeah, I think it is. So you can answer which one is definitely not tidy. Okay, D got a lot of vote. Good. Okay, good. So looks like A is, oh, some people choose A. Okay, so B and D get most vote for not tidy. Okay, so let's look at D. So D is not tidy because they put 2 value in one column. So I don't know if the person is trying to calculate something. So do this slash, or this is just slash to separate 2 value. So I have no idea if it's like doing a calculation or something. And if you notice here, it says CHR, that means character. And that means this part is a character, not even numeric value. So it's a wrong data type too. Okay, and some people say B is not tidy. B got the second most vote for untidy. So yes, it is untidy. So the reason is that if you have this thing called case and then population. So the count here, it's not really very, it's really hard to do any calculation here. Can you do an average? No, because it looks like 2 different set of data. One is very big, one is very small, and they are different type. One is just the number of case, the other is population. So they should be in different columns. So later when you do some calculation to one column or to one variable, you should be able to do that to one column, but this one is just not possible. Okay, so this one is out, and now we only have A and C. So let's look at C. So the problem with C is it has this 1999 data, 2000 data. So let's not talk about if it's tidy or not. First, it's not very good to just use number to name the name your variable, because it will mix with the value here. And you shouldn't do any like calculation like addition or subtraction with the variable name, right? So it's not good to do that. And then if you have, this is just 2 years data. If you have like 10 years of data, you will have a very wide data set. So the feature of a tidy data set, usually it's like long. It's long instead of wide. So if you have like different years of data, you should have a column called year like this one. And then you put the value in the other column. And then so you have 1999, 2000, 2001, 2002, like this, instead of like this. So this one is not tidy. And then we have this one. It has everything in every cell only have one value, and they are like belong to the same variable. And then you have year here, it's separate, it's not in different columns. So this one is a good tidy data set. So why you should make data tidy? So you will have a consistent data structure. It make your life easier and make other people who use your data's life easier. It fits a standard recognized by the R community. So when people say your data is not tidy, you know what that person is talking about. So if it fits the community standard, then other people can reuse your data, and it saves other people time to clean up your data. And then it's also easy to plot tidy data in ggplot2. So ggplot2 is designed to visualize tidy data. And some other popular R package are designed to work with tidy data. So it's good to get your data tidy first before analysis. Okay, so we are going to use this package called tidyr. It's within tidyverse. So we are going to talk 4 functions inside tidyr. There are unite and separate, gather, and spread. So they kind of like look similar, but I put them in a pair because function here, they do opposite thing. Function in this pair, they do opposite thing. So, but unite, gather, it's kind of like similar thing, you know, just put things together, and separate, put things in different pile. So I'm going to go into more detail in next slide. So let's look at unite and separate first. Unite, that means you put things together, right? So unite is, okay, I have 4 columns here, and I want to combine these 3 columns into 1 column. So I use unite. Separate, do the opposite thing. I have 1 column here. I want to separate them into different columns. So a very common example will be, okay, I'm taking some data and then I use the date. So I say 2020-10-12. So that's what I have. But you want to use my data, I give you my data, and then you were like, no, I want to see the seasonal change or monthly change. So I want to separate that month thing. So I don't want your month connect with other data. So I want to separate them. So I can separate day, you can separate the day into year, month, and day. So this way you can do monthly analysis. So this is something that you want to separate. Okay, so this example is a bit different, but similar. So I have this data, table 1, and I have century, 20th century, 19th century, and I have year here. So I got this data set, but I was like, no, I'm not interested in century. I'm more interested in year. So you want to unite these 2 columns into 1. So you say, this is table 1. I'm going to change table 1. And then I want to unite century and year column and make a new column called year. And then you will say the separation will be nothing. So you don't want anything in between these 2. So you could use dash, you can use slash. If you want to separate by slash, you just put the slash here. But in here, I just want the year. So that's how I do it. If you want to do the opposite, you get a table like this, but you want to study the century. So you want to do the other way. So you say, I want to do table 2. And then I want to separate the year column. And then what I want to separate into, I want to separate into two columns called century and year. And then separate equal to 2. So how do I get this number? I get this number when I look at this and I count from left and I count 1, 2, and then it cut here after this 2. So you count from left, 1, 2, and then cut here. So you cut everything here. If you have dash, it's easy. You just do dash, or you have slash, just do slash. But since we don't have anything, but you can like count from here. Okay, so just review the previous function you got to try in our car purchase data set. They are opposite function, and separate will separate one column into multiple. So this is the syntax you use. Sometimes people say, because it will remove the column that you have already, like, show. So if you separate this, then you will get this table. So the original column is gone. So if you don't want the original column is gone, you don't want original column to be removed, you say remove equal to false. So this argument will keep the original column. Sometimes it's a good thing to do because you want both. So you can say remove equal to false. Unite, it's the opposite. And then if you want to keep the original, set it to false. Okay. So first we need to load the tidyr package if you haven't already. So if you in this script, you haven't loaded tidyr package, you should do that. So we will do library tidyr, and then remember to run this. So once you load the package, which column would you like to separate? You can type in the chat that which column you like to separate. I think it's pretty clear since a lot of people mentioned that in the chat. Yes, the engine. Because I just have too many things in one cell. Okay, so I want to separate the engine into size and cylinder. So I look at it and then I decide, okay, that uppercase L is the one separate the engine's size and the size and cylinder. So I want to use L as a separator. So it's different from like different type of data. So you need to go through your file and decide what you want to use as a criteria to separate them. So you can use this to separate them. And then once you separate them, I want you to take a look, see if you did it correctly. So in the view window, you should be able to see if you do it correctly. Okay, so as you can see, when I demo, I make some mistake, and it will have this red red X here tell me I make some mistake. So if you try to run that command, it will give you error. So unless you fix it, when you fix it, then it's fine. The red X is gone, and then then this syntax is correct. So you can run it, and then you should see that it's separate, size and cylinder. Okay. So once you separate them, and then you notice that in the last cell, it has hybrid there. So I don't want that hybrid here. I want it to be a different color. So what you can do is you can use this, since that one has a dash. So the separator, we can use dash, and then I can fill equal to right means if there's nothing there, when you see from the right, then fill in a blank. So the rest will be nothing. And then only the hybrid will have hybrid there. Okay, so these two commands will separate engine into 3 columns. So let me try do it here. So in the end, you should get a column is size, one is cylinder, and the rest is hybrid. Okay, I'll leave it here and I'll give you some time to work on it. So if you want to view your data set, you can do uppercase V, and then say view, and then do car. And when you hit enter, you should see it here. You should see your data here. So this is just one demo. And like I say, data are messy in different way. So it will depend on your data. It will up to you to decide where to find the common factor to separate your data set. And sometimes you can use decimal point. Sometimes you can use like counting a certain character from the left to cut them. So some people say in the chat that some data is gone. So there's no undo. So I suggest you to, since you have the script there, just rerun the whole thing, reload the data, because whatever we do here, it doesn't change the car purchase the CSV file. So it totally didn't change that one. So you can always go back and load that, and then it doesn't change anything in that file, CSV file. So if you still have some trouble running the code, you can either ask the TA, or you could save the script you have right now that it didn't work out, and then you could send that to us after the class. So it's easier that if we can see your whole script. So sometimes it's not like you can use one step to separate them. Maybe you need multiple steps if your data is more complicated. So maybe you need to find like a few different common factors in order to separate your data. Okay. Let's try to move on to next function, next two functions. So you could use gather and spread. So gather is you gather the column here and then make it into two different columns. And spread is doing the separate, the opposite thing. So an example here is like, if you remember, I think this is table C that in my like those slide that ask you to decide which one is untidy. So I want to make it more tidy. So I want to gather it. So what I need to do is I want a column called year, another column called case. So what I do is I want to gather this, and it's table 1. I want to gather these two variables, 1999 and 2000. And there are two arguments you need to put in. One is key, one is value. So usually I look at it backward. I put value as those numeric input. So I put value here. So that's like number, right? So this is your number. And then key is often some character. So even you see 1999, it looks like numeric data, but it actually should be character data because there's no meaning about adding this to up or adding these 2 years up. It's just like character data, mark the year. So that's your key. So key is your year and value is case. So you gather them together. And then you could do separate, like this case. This is, I think, table B we saw before. And you want to spread them into two variable, two column. So what you do here is you do table 2 and you spread them into, spread the type and count into this 2. So it will put case here and pop here and then spread it for you. Okay, so this is just review. It's an opposite function. Gather will collapse multiple column into 2 column. And then if you say NA.RM is true, that will remove the missing value. You can use column to select multiple continuous column. And you use minus to take away column. So maybe you want you want multiple column, but you just want to take away one. So that way it will be easier to do minus. So you just take away one for you. You can do spread, and then you could do fill equal to NA. So it will fill the empty cell with NA. Okay, let's look at our data set. So which function you want to use? You want to use gather or spread? I'll give you a hint. We will modify the male and female column. So what would you like to do? Okay, let's skip that because someone asked a question. Okay, so gather is you gather multiple column, right? So if multiple column, you have 10 column, but you just want 9 of them, you want to gather 9 of them. So it's just too much to type each 9 of them. So you can just say minus to take away 1 column. So there is one that you don't want. So you use minus that you don't want to take away that column. So demo one of this later. But this is not just in gather or spread. It's used more generally in R. If you want to take away something, you use minus. If you want to select something continuously, you do from something and then to something. So this thing means like from what to what. Okay, someone say use gather. So I give you a hint that we should gather the male and female into gender and purchase number because we want to know the gender in one and then how many cars this gender bought in a specific type and model. So first you need to decide your key and value. So value, like I say, it's number, numeric usually. So in this case, it's the purchase number and your key is the gender. So this is what you can do. You use gather, car, and then key equal to gender. Value is purchase number and want to select column male to female. So I'm going to type it here. So you should get something like this: gender, male or female, and then how many cars they purchase for each car type and model. Okay, I'll leave it here so you can see the code. Let's see. Okay. we're almost done with this data set. So once we are done, we can, we'll take a break and we will go to the next data set. Okay, so if you are typing all this command, just remember to save your file so you won't lose everything. But don't worry, you will get something after the class and you can practice that at home. Okay, so the data looks better and better now. So this is just something to check your understanding. If you want to combine 3 columns into one, which function should I use? Good, unite. Okay, so before we get into more detail, I want to talk about dplyr package because this is a very useful package too, and we are going to use some of the function. So mutate, it add a new variable that are function of existing variable. So if you are doing some calculation, you can use mutate. Like if you have height and weight, you want to add a column called BMI. BMI is calculated from height and weight. So you can do mutate and then add a column called BMI and do the calculation. You can use arrange to sort your data by variable. Select and filter, these are 2 functions to subset your column or your rows. So select pick the variable based on their name, filter pick column based on their value. So I usually remember it as select the column, filter the rows. So just different direction. Summarize, it provides some summary statistic for your data set. It usually work with group by. So you can group by gender, group by age, group by year, and then do summary statistic. You can learn more here And if you are interested, you can come to our manipulating data workshop on Wednesday. I'll show more example in that workshop. But let's finish the cleaning now. We need a dplyr package. So you could, if you haven't already, you can load the dplyr package. So someone mentioned a question that, oh, they see some NA in the purchase number. They think it's better to use 0 instead of NA, so which I agree. So it's a good question. And actually that's something we are going to do right now. We want to replace all those NA because I don't like it there. It shouldn't be there because it's not NA, not like you don't have data. It's like that there's no one bought those cars. Okay, so this is what you need to do. And then this is the subset. So this command just tells you that in this variable, the purchase number variable in that column, if you found something that is NA, assign 0 instead. So I'm going to do that here. So all your NA is replaced by 0. Okay, so the command here will be a bit complicated, but just type in there. If you use if else before, that will be more easy to understand. First, you need the dplyr package because we are going to use the mutate function and case_when function. So case_when is more like if else statement if you are using other programming language. So of course you can use if else in R too, if you want to, if you feel that's more comfortable. Okay, so I'm looking at this hybrid column and let me jump back. I look at this hybrid column and then I was like, I don't like NA because NA means no, it's not a hybrid. And this hybrid actually means yes, it's a hybrid. So I don't want to use NA and hybrid. I want to use yes or no. So hybrid, I say no, 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 yes, no, 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 yes. So this is what I want to see. So I don't want to see this because that's just too hard to understand. So in order to do that, I'm going to use this. So first you need to load dplyr. And this tells you this car data set, I want to mutate. And then I want to mutate a new column called hybrid. And then when it say NA, type in no, replace that with no. When it say hybrid, type in yes. Anything else, just say NA. So in our case, there's no anything else because it's either NA or hybrid. But if you have a big data set, there may be some other situation you never consider. And it's good that you type in this else to tell people something else, you assign NA there. Okay, I know it's a long one to type, so I'm going to give you some time and I'm going to type in here at the same time. So what you should get is hybrid, no, 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 yes, and no, 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 yes. Should get something like that. Okay, so this one is pretty complicated, but hope you are able to get it. So if you are used to if else, of course you can use if else statement if that's feel more comfortable for you. Okay. Let's move on to next one. Okay, once you get the data set, maybe you want to save the clean one, or maybe you want to keep working on it. So my suggestion is always keep the original. Don't overwrite the original one, even you think it's messy. So if you have the original one, you can always go back, change the run the code and clean it. But if you overwrite it, you can never come back unless you have some other way to download it again. So always keep the original, and you can save your clean one to a CSV file. The function you use is write.csv. So you can say write.csv and want to save in that data folder. And it's a better data set. So I want to call it better underscore car purchase.csv. I set the row names equal to false. The default is true. So you are welcome to try not to set it. Don't put this argument, and it will give you an extra column on the left, and you will say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's just an order, and that's something I don't want. It's not important to me, so that I want to just remove that part. So I'll say false. So you have the original data set called car purchase. Nothing changed. It's still there. It's still messy. But now you have this new data set that's good, clean, and then it looks better. Okay, so let's just save that data set. So if you go to your data folder, you will have this extra CSV file that you save. But the original is still here. Okay, so once you are done with this, I want to take a little break. So it's 2:37 right now, and we will take a 10 minutes break. and we will come back at 2:47. You can use this time to take a break, or if you still have lingering question, the TA and I will be online, so you will be able to ask some question. Okay, so that's reconvene at 2:47. Okay, it's 2:47, so welcome back, everybody. So we are going to have a different data set now, and it will be different than the previous one. So like every other class, the instructor often demo the easy one and then leave the hard one for you to do homework with. So this is kind of like this. So this one is a data set called HoneyRaw _ 1998 to 2002. The data set I give you, I have three HoneyRaw data set from different year. So this one is the one I'm going to show you right now. The data source is from Kaggle. If you don't have any data available for you to practice and you want to find some real life data, I suggest you to register a free account in Kaggle, and you can download many interesting data sets. And we will clean the data set using the commands you learned from this workshop, like in tidyr and deployr. But the first step, like I say, you need to decide the step to clean the data set. Don't just like see something messy and then just clean that part. So you should look at it first and then decide where you are going to start. So I'm going to try the breakout rooms, and then you will be put into a breakout room with some other people attend this workshop. And I want you to open this, not load this one, but just double click the CSV and open it, and then go over it and then make up some stuff that you want to clean. So you don't have to, so when you do that, you don't have to worry about, do I know how to do this in R? Do I know any function to do this in R? I don't want you to worry about that. I just want you to think about what step you want to take to clean it. So I hope each group can come up with at least one step we discuss here. And then this is a Google Doc that I hope everybody can edit. So you can type in your step here. So you can decide. Somebody asked if we need to start a new script. Not yet. So this is just not even script yet. So we are not thinking inside our function or our command or our script or anything about R. We just look at this data set. So let me see. Let me see if I can open that data set. Okay. So what I want the group to do is look at this data set and then think, oh, how can I make it tidy enough to analyze? So what step do you want to take? Don't worry about if you can do it in R or not. Just think about the step first. Okay, so let me try I hope everybody can access this. Let me see. Let me copy and paste this to the public chat so you can access that. And I'll do a breakout room. I'll give you 15 minutes. So we will be back at 3:05. And you could first introduce yourself, turn on your video and audio in your group. It will only be heard in that room. And then if you need help, you can call for help. Okay, we try this. Okay. So I'll send a reminder, but we will be back at, okay, 3:07. Okay. Let's see if I can.
Oh.
Okay, I hope I got everybody back. So thank you for joining the breakout room and do the discussion. So I hope that you all get a good look at this data set because this is important for you to start cleaning data that you need to think through it. And I saw some people typing some good stuff. Okay, so let's just look at that. Let me show this little bit. Okay, so by just looking at this data set, you will realize that, oh, it's actually not good for immediate analysis because there are so many like extra information here. That's not very helpful if you want to calculate the column mean here. And you see here, okay, it looks like the state, but there are some other things that that's not relevant. And there are also some footnote here. And you get another year. So there are 5 data set, looks like this. Like this is 1998, 99, 2000, 2001, and 2002. So but those year information is not somewhere you could see here, right? So if you combine with other data set or if you combine, oh, actually, I think the year information is here, but it just represent by 1. So 1 means 1998, 2 means 1999, and then 3 is 2000. So you kind of need to combine those year info, put those year information in here. So later we can combine this data set with other data set that in your data folder. And then also like this has 1,000 pounds. So maybe you don't want to do 1,000 pounds, you just want the actual number. So you need to times this by 1,000. And then the ideal data set will be, it has different value, and then each column will have the same, like this is numeric, so everything here should be numeric, so you can do some calculation. So I look at this sheet and it looks like everybody get good answer. So, okay, now let's go to the data set and we can do some cleaning. So let's start a new script because we will need that. And then the first step is to load the file. Okay, so let's forget about car data set and we go to a new file, R script. Okay. So this is called Honeyrod 1998 to 2000. So let's load it. So I'm going to call it Honey 1998. I use read CSV. So header, I set it to false because if I make it true, it will recognize the first row as header. But actually the first row in that CSV file, it's not header. It's some random metadata information. And that's not the header I want. So I'd rather just like, don't recognize it as header. I delete that later and then I assign my own header. That's why I put it like false here. And then I want blank cell to be NA. And then also there are some NA in there already. So I want those to be NA2. So if you run this successfully, you shouldn't see any error here. And then if you do view honey, you should see the whole thing here. Okay, this is just something I just type. And remember, since you spend so much time typing, you should save it. Remember to save it. Okay, once we got the data set, we should examine this data set. Actually, I don't think it means much to examine the data set since it's not really a lot of information there. I haven't changed it to the way I want. So, okay, let's skip this for now. Okay, I want to rename the column because if you remember, I didn't put in anything in there just because I don't want to, I didn't ask, I say header is false. So now I want to give it a name. So this is the name that I want to assign it. Year, type, state, number of column, EO per column, total production, stocks, price per pound, and production value. And this is how you rename your column. So right now it's just say V1, V2, V3, V4, but I want you to rename it to the name that we can use later. So of course you can give other name, but since I'm using this name and the following command will follow this name, it's better that you just use the same name. Okay. Type it in R right now. Okay, so if you run that, it will replace by the name here. Okay. So it should be the name that you just assign. So next step is that, okay. Next step is you look at this data and then can see this T, H, U, and D. There are metadata explain what's this mean, but the metadata is in the data sheet from Kaggle. So here I just tell you this is like title, this is header, and D is data. So what we want is the data part and U is unit. So I only want the data part. So I don't want anything else because other things are just metadata. So I want to take away those, wait, need to go through this. Okay, so when you are doing this, you may be wondering why we just not do cleaning in the spreadsheet first, because we can use the spreadsheet to clean the data set, and then we can move it to R and then start to do analysis. That's easy, right? Especially for people who are used to do spreadsheet. But the problem is it's not reproducible. So it's really hard to explain to people, like in your paper, okay, I download this from Kaggle and I did some step, like I delete this column A, I take away row 6 to 9, and I did this, I add that, and then you got a clean data set. So that's not really very reproducible. And then also because here is just one data set, but if you have more data set you need to clean in the future, it's better to have a script so it can do that all at once instead of like doing the repeated step in spreadsheet. And it's also bad because if you didn't write down the step for the first one, how can you be sure that the second one you follow the same step? So that's not very reproducible. So I suggest you, when you clean it, you do that in R. Even sometimes you feel it's a bit harder compared to what you did in Excel before, but don't worry, when you are getting better, it will be easier. And there are some column and rows that you don't want. So if you remember in dplyr, their function can do that. So select will select the column we want, filter will filter the rows we want. Okay, so what do we want to get rid of? We will use the filter function first. So like I just say, in that data, I only want the part that has D in front of it because that's a real data. So that's something I want. So since it's in dplyr, I want to load dplyr package first, and then we can choose the one like type is equal to D. So we can filter that. Okay, let's load the dplyr first. Okay. I look at this, I only want the type equal to D. I only want to select this row. So that's what I'm going to do now. So when you are done, you come back and look at it. Oh, that's much better, right? That's much better than the messy data set we just import. So this looks like more like some data that we can start analyze. Okay, and then we will see what we can do now. Okay, there's still some stuff that I don't want, like the state column. It has each state, but there are some like other that I want to get rid of. So I will use distinct and filter. So first I want to find out the unique value for state. So I want to know what value, because this is a long data set. So I don't know what happen in the state, what value people put in. So I want to find out the unique value, and then I will decide what I want to get rid of. So distinct give you the unique value of that column. Okay. So if you run the and then you look at the result. Okay, I got like, this looks like state, each state, abbreviation for each state. Oh, there's an NA here. There's an OTH here, probably others. Stack 3/ US 4/ SC, South Carolina. So it looks like there are things I want and there are things I don't want. I don't want this like NA other stack US. So I look at that and I was like, oh, okay. Looks like I can keep everything that have number of character equal to 2 because all the state aberration have 2 character. So I only want to keep those. So if I want to keep those, I say filter because I want to filter those. Filter those row with state name there. So this function I'm using here, NCH, is the number of character. So I want the number of character in the state column equal to 2. That's all the state aberration. So someone asked what is D? D is data. And then someone asked if we remove the row other than state, I will lose data. So yeah, we will lose that part of data, but then it's up to you if you want to lose that or not. So if you want to include that, then let's see. So when I clean this data set, I think other doesn't include data. I think it has like other doesn't have any data in there. So that's why I decided to remove that one. I think this two is just some calculation from the above, but I need to go back to the metadata to make sure. Okay. So now we have that, and then our data is looking better and better. So like I say, I want to recode the years because this is just this data set. If you look at other data set after 2002, you will find that they also use year as 1, 2, 3, 4, 5. So if we combine these two data set, this data set with later year, we will think that year 1 are all from the same year, but it's actually not true. It's the first year in that data set. So I want to put the actual year in there. So if you remember when we did the car data, we use mutate and case when. So this is the two functions we are going to use. we will recode 1 in year column to 1998, 2 to 1999, 3 to 2000, 4 to 2001, 5 to 2002. Okay, so this is what you are going to do. Mutate this data set, and we will create a new column called year, lowercase y, equal to case when. So when the uppercase year equal to 1, assign 1998 to it. When it's equal to 2, assign 1999 to it. When it's equal to 3, assign 2000, equal to 4, assign to 2001, equal to 5, assign 2002. And anything else, do NA. Okay, I'll type it in here and then I will answer question and give you some time to work on that. Okay, I hope everybody is able to get the same thing like I do. I add a new column here and it has the year and 1 is 1998 and 2 is 1999. So it's good that you check, like, are they the same as what you expected? Year 1, 1998. That's 5, 2002, 4, 2001. Okay, that looks like it. So hope you got it correct. Okay, so right now the data is quite clean, but there are still some column that I don't want because like the year column, year equal to 1, 2, 3, 4, 5, that's something that's not really helpful now because I have a new column called year and it has more information, better information than just 1, 2, 3, 4, 5. So I'm going to get rid of that. And also there is a type column that has D. If you remember, D means data. But now since I select all the column that type is equal to D, then everything is D now. So there's no need to keep that column there. So I'm going to get rid of that too. I'm going to use select because now I'm doing the column, not the row. And these two are the one I don't want. I want to get rid of it. So if you remember, I mentioned you can use the minus sign before when we do, I think it's the gather function. And I think it seems like people are confused with that, but you can rethink about that right now here. I want all the column, but just year and type. I don't want those two. And then of course you can spell out all the column then, like from all other column, like stay and then lowercase year, price per pound, something like that. But it's like about 10 variable name you need to put in here if you want to do that. But it's much easier because I only don't want two columns. So I just say minus those two and then it's gone. I don't need a very long command to accomplish this. So that's the very useful thing about this minus sign. Okay. So let's just do it here. So you should see those columns gone. Okay, so sometimes when you type things, I always remind people, remember to, if you start a left parenthesis, close it with the right parenthesis. If you start a second one, close it. So remember to do it. But sometimes because R is really nice, like if you type in one parenthesis, it's finished for you. But sometimes it doesn't do that. So you just need to be careful. Every time you start it, you count two parentheses here, you count another two on the right, two on the left, two on the right. So sometimes that will cause error if you are not careful. Okay, that's just a side note. Okay, so you can also convert the data type because if you, now we can use the structure. Okay, let's do structure. Honey. Okay, all of them are character, but only the state I want to be character. I want all others to be numeric because those are number. I'm going to maybe do some calculation later. I cannot do it with character, so I want to change that. So I use structure to check what I got, because sometimes when you load file, it depends on the function you use. Sometimes it are just like change the file type, the data type for you. It didn't ask you if you want to do it. It just changed it for you. So it's always good to use structure to check. And then it's also could because that when we load the data set, we have those top rows that's character. So according to the coercion rule R have, it just coerces that O into character. So that's why we got all the character. So I want to convert all the column. No, all the column except the first one to numeric because the first one is state. So state will stay in as character. So first I tried that and then it didn't work. It said this object cannot be crossed into type double. So the problem here is that it's a this project. And so we need to unlist it. So in order to unlist it, it should add this unlisting. So this is another thing that R did, that it just like pour in the data and then assume it's a list. This is a data structure in R. So, okay, so if you want to convert the data type, you need to unlist it first. So let's do this in RStudio. So once you run this, you can see the structure again. And then they are numeric. I leave the year as character, just like I explained before. I think year should be character, not numeric. So list is a data structure, and then it can include data. It can include different type of data. It can include character. It can include numeric. It can include integer, logical. You can put different data type in a list. So a list is so the data frame are usually the one we use, the most common one in R. Data frame is a special case of list. So list can have data with different lengths, different size, but in data frame, the data should have the same size, so the same length. So like this one, data you should all have 217 points for each column. But list can have different lengths. Okay, now we are done with that. Now I want to change the unit. I don't want to, like somebody point out that there are some things say per 1,000 pound, but I want to make it per pound so it's easier to compare. So I'll use the mutate because I want to create a new column and with like this number times 1,000. Okay, so this is almost the last one. So you are almost done with cleaning this. So you notice that here I hit enter and I switch to a new line. You don't have to do that. It's easier for other people to read. If it's too long, then people need to scroll to the left to see the whole thing. But if you hit enter, it's the same thing, but it's easier for other people to read. So you can break at different place. It doesn't matter. So these are the same as the previous one I did. So it just for, it's easier for others to read. Okay, once you save it, no, once you got it, then you can write it into a new file. Use write CSV. So if you notice here, I changed the name. It's not called honey it's called honey underscore. The original one is honey raw underscore. So it's a different name. So you won't override the previous one. So remember to save your script. Okay. Now this is really a homework for you. So I save it. Okay. So the homework for you is there are two other data sets. So you can clean up the rest today when you get home, or when you receive my email for I think my email, I will send you the complete script for clean up all three data set. So it's not as easy as copy and paste, because not all data set are the same. It may be taken different year by other people. So just a hint here that I think this data set is spelled out the state name. So instead of saying MD, it's spelled out Maryland. So it's a different way to, you need to clean the data. But I want you to like go through the data set at the beginning before you copy and paste everything. So you can use a script you wrote to clean up these two data sets, and then just make sure you check the original CSV file. And then in the end, maybe you want to join all those data together, and then you can, you will learn join data in our manipulating and join data workshop on Wednesday. But just for now, you can use rbind. Rbind is a function in base R, so you don't need to load any package. So it basically just a copy and paste. So it's copy, load, and paste to another data set. So if just before you do that, it's only a copy and paste. So it doesn't care which column code what name. So make sure that all the order in your column are the same. Otherwise, you will copy and paste different set of different data without realize that. Okay, you will see that in the script that I sent you. And then in the end, you will get a huge data set from Honey data set that's from 1998 to 2012. So in this case, then you can analyze the honey production over this year, 15 years, I think. Okay, so we have a few minutes left. So I want to go over some best practice for data cleaning. So like I say, always keep the original, doesn't matter how messy it is. So don't clean the data directly in the spreadsheet because it's just not reproducible and reusable. Make sure to check the data type when you clean it, and then because sometimes it will change. So remember the data type is something you want, and always check if you get the desired result if possible. If you have a huge data set, check a small subset, just randomly pick few small subset and then to check. And if you want to learn more, there are some more talk about tidy data, and this is an analysis of admin data. Janitor package is like cleaning, right? So it's another data cleaning package in R. And db-pry-r, it's not dplyr, it has db, so it's work with database. So it doesn't use the SQL syntax, but it uses dplyr syntax. So you can, you don't need to do SQL query. You just use dplyr function directly and analyze those files in database. There are some cheat sheet available that you could take a look. There are some YouTube channel by School of Public Health Professor Roger Penn. So he has some useful one, and usually not very long, like 10 minutes. So I think it's a good like lunch learn. This is a website. It's has a lot of good information about R. Introduction to R. This one is another professor in School of Public Health. He actually have intersection class about R, like a week, like every day, half day. You can take a look because he shared his slide and also have a question that you can practice. So if you are looking for question to some more data to practice, I suggest you to take a look at that. This one also have a lot of information, I think it has 10 class, not limited to R. So it'll be useful if you are interested in data science. This one is about data processing and visualizing. And I saw some people use OpenRefine. So if you want more graphic interface thing, OpenRefine is a good option. So some workshop, conference, they probably are all virtual right now. So if you like to sit at home and pay, sometimes they are cheaper. So you can take a look at this option. And this one happened in October 20. I don't know if they have space, but you are welcome to check. It's a meetup event for our ladies, but doesn't mean if you are a guy, you cannot go. You can still sign up, but it talk about how to use R Markdown and workflow R to document your workflow. So if you are interested, you can check it, sign up, check it out. Otherwise, they have other event. It's good to check out too. So if you came to my intro, you know the biggest secrets to master R is just do it. So don't wait until you read everything. Just do it and try it out. And practice, practice, practice. So there are some data source you can use. And if you did something in Excel or Stata before, I think a good practice is you try to do a same analysis, the same data cleaning in R, and then see if you can get the same result. So practice to do the homework today. And then I think this link is another person try to clean the data set. She doesn't use the same thing as exactly the same thing I do, but it's good reference. And my way is not always a highway, so you are welcome to adjust it based on your need. And you could try to import your own data. You can reshape your data set, try to recode the value, and then you can review some relevant cheat sheet, explore janitor data package or db-plyr if you are interested. And if you are interested in watching somebody do live coding, I think that's a very good experience just because sometimes for beginner, they will feel bad that they make so many mistakes. But actually, if you see some live coding thing, it's actually not too bad. Like even experienced coder, they make mistake too. So don't feel bad about it. Like at the beginning, I also make some mistake when I type in the comments. We have some advanced one. This is the one you are taking. This one happened on Wednesday. This happened in next Monday, and this will happen in December 8th. You will get a flyer about this reproducible workshop. If you want to register, you can do it here. I think these two are on wait list, but it's okay. Just put in your name. I will send you the email. Even you are on wait list, unless we have 50 people on the wait list, which is not happening yet. This one is not full, but maybe you could sign up and put that on your calendar. It's a one-day thing. Please take our survey, and our survey is always the thing we use to improve our training and workshop. And yeah, I think Marty put the survey link in the chat, and then please take it and then help us improve our workshop. And thank you for coming. And we still have 7 minutes. I will stay online until 4, and you are welcome to use the time to fill the survey or ask questions. And thank you. I hope to see you on Wednesday.